It's sort of like, you know how NASA used to send a record into space, like a Chuck Berry record on the spacecraft, and it would have a picture of a man and a woman, and it would have the numbers 0 to 9, and a record representing what people can do. I feel like if you had to pick one part of the genome, human genomes, to represent the amazing diversity of how the genome is relevant to phenotype, and the amazing relevance of the genome to human history, how it can tell us about human history, HLA would be that representative part of the genome. It is the epicenter of human genetic diversity. It is the most diverse base for base stretch of the genome that you could possibly call out. And some of that diversity is incredibly old. It goes back to, it predates human gorilla divergence, so that I might share a haplotype of HLA with a gorilla that is we're closer in that part of the genome than I am to you. And vice versa, that gorilla to me than, closer to me than another gorilla. And that's amazing in itself in terms of history, but then if you think about what other part of the genome is relevant to narcolepsy and drug response and all kinds of autoimmune diseases beyond narcolepsy and all kinds of other phenotypes. Whenever I do sort of a whole genome-wide scan for variants that are, or segments of the genome that are relevant to some phenotype, you can reliably expect that 6P is going to show this peak. And you're going to say, aha, there's HLA showing up yet again as relevant to some particular phenotype, some particular drug response that you're trying to understand. So if you had to pick one part of the genome to know about, to be fascinated by, and to be able to call well, HLA is it. And unfortunately, it's also the hardest to call well.